Hello, welcome to lesson 4 of the interest and depreciation workbook, this time looking at compound interest and future value. Compound interest is the way that most of the savings accounts, loans, mortgages, etc. that you are going to get later in life will work. So it's pretty handy to know how these things work. So what's the difference between compound interest and simple interest? That's the main thing. The first paragraph explains it, and it says that when money is invested at compound interest, the interest that's earned at the end of each time period, so most savings accounts usually will pay you your interest every month, is then added onto the principal and included with the interest calculation that they make at the end of next month. So this increases the principal that is used to calculate the interest from one time period to the next. Like I said, usually months, could be years. So with that, you are actually earning interest on top of your interest. And that's what this last section is. It's saying that the interest from one month will roll over to the next month and have interest added onto that little section as well. This is pretty powerful, and it means that interest with compound interest grows much more quickly than it does with simple interest. Even if the rates are the same, sometimes in fact a compound interested savings account with a lower rate will be better in the long run than a savings account with a higher interest rate, but where it's just simple or flat rate interest. And it's something that's worth calculating, worth looking at when you do start to shop around for interest rates. So it's important to remember how percentages work. If you're increasing an amount by R%, what we can do is we can multiply by 100% plus R%. So for example, if you're an increasing amount by 8%, you could multiply it by 100% plus 8%. Why do we kind of make this point here? Well, it's because of the formula that we're going to use. So the formula that we're going to use to work out compound interest is going to be A with a subscript n is equal to P 1 plus R to the power of n. What do all those parts in the formula mean? A to the n is your account balance, so how much money you have in your savings account after n time periods. N is just a subscript, so it's not a variable in the usual sense where it's being multiplied or powers. It's just to keep track of after how many years or months, whatever, we have worked out for. P, as before, is principal. 1 plus R is what we've got up here. It's our way of increasing the amount of money in your bank account by the 100% that's already there, plus an extra R%, the interest rate that you're getting on the account. Finally then, N is the number of time periods. That works the same way as the P, R, and N formula previously. So N is the number of time periods where the interest rate and the number of time periods have to be measured in the same way. So the interest rate is mostly commonly given per year, per annum, P dot A. If you're looking to work out the amount of interest that is given after, say, 30 months, because your time period is measured in months, you would have to change the interest rate into a monthly formula as well. So we'll look at some examples when it's nice and straightforward. Bear that in mind, particularly for the harder questions and in HSCs, they are going to look to complicate things by making R and N be measured in different time periods. So first example, $2,000 is invested at 3% per annum, and it's going to be compounded yearly. In other words, the interest is applied at the end of every year. A to the n, as we said above, a subscript n, is the amount of the investment after n years. So find A3, the amount of the investment after 3 years. So let's substitute into the formula we had above. A3 is equal to the principal, $2,000, multiplied by 1 plus the interest rate, it has to be as a decimal, just like it did previously. So 3%, back up here, 3% is 0.03, and it's to the power of 3 because the investment has been made for 3 years. You, of course, would use a calculator to work that out. You wouldn't do that one in your head, and you will find that you get 2185.45. It's money, it's dollars, so put the dollar sign at the start. So that is how much is in the account after 3 years. Remember, in simple interest, you're working out the interest, but here you're actually working out how much is in the account. So we started with $2,000, and if you wanted to work out how much interest had been earned, you would take the closing balance, 2,185.45, and you would then take away the starting balance. So the amount of interest that's been earned here is $185.45. This particular question doesn't ask for it, but many questions, especially in the textbook later, will ask you. Okay, the second example, calculate how much interest was earned in the 3 years. That's what we've just done there, in fact. So we've worked that one out. Interest is how much is earned in the 3 years. Closing balance, take away the opening balance, and you'll get the answer from that. So part C, find A5, the amount of the investment after 5 years. Well, it's pretty much the same as what we had earlier. It's still the principal of $2,000 multiplied by 1 plus 0.03. This time though, the difference is that it's for 5 years, so the number of time periods is 5. Put that into a calculator. It won't say this exactly. What we have to remember is we're using some money. So it's going to be $2,318. And when we round, you'll find it comes to 55 cents. So don't forget, money is always 2 decimal places. In D, determine a formula for A to the N. Well, we've already had that at the start. It is this formula here. Wouldn't expect you to actually go through and derive the formula at the start using the other things. Bear in mind, a lot of textbooks actually don't worry about this N here. So in a lot of textbooks, it'll just say A is equal to P1 plus R to the power of N. So don't be surprised if you get a different textbook, look online somewhere else, and find that it's explained slightly differently. So we'll next move on to the next slide. So on the next page of your booklet, it talks about a slightly more complicated example. If we just read through it quickly, it asks if $12,500 is invested at 4.8% per annum with interest compounding monthly, and this is very important. So the interest is applied to your account at the end of every month, not at the end of every year like in our previous example. We need to calculate the final value and amount of interest. So the final value, that's A, and then separately the amount of interest that's been earned after 2 years. So you may want to start this by thinking, well, okay, it's after 2 years, so I'm going to work out A2. But in actual fact, we're going to work out something slightly different. So you might remember at the start of the video, I said that when you have got the interest compounded monthly, the interest rate has got to match that. So in fact, we're not going to use 4%, 4.8% per annum. We need to turn this into a monthly rate. How do you change that into monthly? Well, just like previously, you need to divide that by 12. It also means that the number of time periods is going to change. So the number of time periods can't be measured in years. The number of time periods has to be measured in months. because it has to correspond with when the interest is compounded. How do you turn 2 years into months? Well, you multiply that by 12, and of course that is going to be 24 months. So to start with, when I calculate the final value, A, I'm actually going to make it A and then subscript 24 to say that it's the final value after 24 months. Then we can substitute in the other things as we usually would. So the principal is $12,500. The interest, the second part is 1 plus the interest rate. The interest rate as a decimal would be 0.048, but we remember that that was yearly, and to make it monthly, we need to divide it by 12, and then it's going to be for 24 time periods, 24 months. You put that into a calculator, and you will find that it comes out to 2 decimal places as 13,756 and 85 cents. So after 2 years, 24 months, the amount that's actually in the bank account has risen to $13,756.85. How do we find the amount of interest? Well, as before, the interest that you've earned is the difference between your starting account, and your final account. So we take the final account balance of 13,756.85, and then we subtract the starting balance of 12,500. And that comes to, we'll include the units again, 1,256.85. And that's that. So, as the book now says, if we scroll down, you should be looking at exercise 804. As always, the questions that you should be attempting are written on the inside front cover of your workbook. And if you've had any questions about this video or the questions in the textbook, then do ask.